Okay, welcome to lesson 6. In lesson 6, we're going to continue with the idea of rotations, but specifically rotations of 180 degrees, which is, as you know, halfway around a circle. And we're going to look at what rotations of 180 degrees do to points on the coordinate plane. And we're also going to learn that when a line is rotated 180 degrees around a center O, or whatever the center of rotation is, as long as the center of rotation is not on the line, it will produce a parallel line. So we're going to formally prove that and see lots of examples of that. But we're going to start with this example right here, which I'm just going to talk you through. So we learned in lesson 5 that if I have a point, such as P, and I rotate it 180 degrees around a center, that its image lies on the same line as both O and P. So PO and P prime will be collinear when I rotate 180 degrees. So we've seen that. And so if you look at this diagram here, what I have are two intersecting lines, and there's an angle formed by the intersecting lines, 4 angles formed. And you may have learned before that these angles that are opposite one another when two lines intersect are called vertical angles, and their measures are equal. And that is a direct result of rotation. And so what we have here is we have P, O, and Q, which are forming angle M, and Q prime O, P, which are forming angle N. And due to the fact that these are on the same line and these are on the same line, what we have is an angle here that is being rotated 180 degrees. And when I do that, because I know that those points are going to end up on the lines over here, I know because angle measures are preserved in a rotation that this angle must equal that angle. So vertical angles can be proven to be equal in other ways, but rotation is a really quick, slick way of proving it as well. Okay, so that remember that fact that these 3 points, the point, the center of rotation, and the image of the point will be collinear when we're rotating 180 degrees. Only with 180 degrees is that true. Okay, so let's look at the coordinate plane. Okay, and this picture shows what happens when there is a rotation of 100 degrees around center O, the origin, on the coordinate plane. So, so let's look at what we have. Let's mark our center of rotation is the origin on the coordinate plane. And if we have this point A, we know that point A prime, its image, has got to lie on a line through A and O. So those 3 have to be on the same line. Not only that, they're going to have to be the same distance from the origin, because distance is preserved on a rotation. So when we rotate this, if we look at what are the coordinates of point A, 2, 3, 4, this is the point -4, 0. And the point A prime over here would have to be the same distance, 1, 2, 3, 4. So this would have to be 4 because it's on this same line here. Coordinate, the y coordinate would have to be 0. So the points A prime is, the coordinates of A prime are 4, 0 right there. Now, let's look at point P and P prime. So if I have P here, what I have is kind of an angle there, or a triangle, you could even think of it. The coordinates of P are, the x coordinate is the same as A, so it's -4. The y coordinate is +3, right there. Now, this angle is a right angle. And so when I rotate this 180 degrees, I've got this situation going on. So I know that this distance and this distance have to be equal because the distances are preserved in a rotation of figures like this. Therefore, my point P prime, this distance has to be 3, and the x-coordinate has to be the same as the a-coordinate. So this is going to be 4 and -3. Because I know this distance and this distance have to be the same. Coupled with the fact that this line, these points are going to fall on the same line. So what we've proven here is that if I have a point AB on the coordinate plane, rotation, and I'm going to use some notation here, the rotation around the origin of AB is going to be, let me move it down here, is going to be the point opposite of A, opposite of B. All right, so if we look at our point P up here, A is -4. So the opposite of -4 would be +4. B is +3, and the opposite of +3 is -3. So we're going to use this notation to help us figure out the coordinates of a rotated point.